Okay, so we are going to do review for exam 3 today. So the first one is the body temperature in degrees Fahrenheit of randomly selected normal and healthy adults are shown below. So these are our temperatures, okay? So the first thing that we're going to do is we're going to put them least to greatest, which is going to be 98.1, 98.2, 98.3, 98.4, 98.6, 98.7, 98.9, oh, 98.9 again, 98.9, and then 99, okay? So that was all of them. Remember, we're going least to greatest. Always. Okay, so now we're going to find the mean. It's the first thing we're going to look for. So the mean is the sum of all of the numbers divided by the total of the numbers, right? So we're going to have the sum of all of them divided by the number of all of them. So if you add all of these up and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? That's going to give us 98.6. Now, we're going to find the median. So that is the middle number, right? Median, middle. So that means since we have an even number, we're going to go to the middle. That's going to give us 98.6 plus 98.7. We add those together, and then we're going to divide by 2. So it gives us 98.65. And last we're going to find is the mode. And the mode is the number that repeats most often, right? T. Oh, shoot. I forgot to get my light out. Light on. That should make you guys just feel like you're right in class. Okay, so the one repeated most often would be 98.9, right? So 98.9. Okay. All right, so number 2. Exam results for 100 students are given below. For the given exam result, briefly describe the shape and variation of the distribution. So we have a median of 75, a mean of 75, a low score of 60, and a high score of 90. So we want to know what our distribution is going to look like, right? So we know that the high score is of 100, right, out of our exam. So we see that our high score is going to be 100. The mean and median are both 75. Low score is going to be 60, and the high score is going to be 90. So the distribution would be symmetric because the median is equal to the median, or to the mean. So that would be what it looks like, right? The difference between the greatest and the least score is what? So our highest score is 90. Our least score is 60, so the difference would be 30. So the difference between the two is 30. Is that a moderate to large or a small difference? Well, that's rather small, right? So it's a small difference. Okay. Okay, let's look at this one. So the table gives the cost of the living index, the COLI, for 6 East Coast counties and 6 Midwest counties. Using the index where 100 represents the average cost of living for all participating cities with a population of more than 1.5 million. Okay, so we're going to answer the parts A through E. But now we're only going to answer, we're not going to do the Midwest. We're just going to do the East Coast, okay? I only want you to do the East Coast. Okay, so as always, we're going to do least to greatest. Okay, so we're going to look down through here and go least to greatest. So that would be 104.7, 123.3, 128.9, 134.9, 141.3, and then of course a little outlier, 114.5. Okay. All right, so we want to find the mean. Remember, you add them all up and then divide by the number that you get. So when we add 1, 2, 3, 4, 5, 6 of these up, divide by 6, our mean is 157.93. Okay, now the median. So we have 6. To find the median, we're going to take the 2 in the middle, which are going to be these two, right? This is going to be for the median. Add those together, divide by 2. That's going to give us 131.90. And then for the range. If you will remember, for our range, we take the biggest, the largest number, our max, and we subtract our min. So that is going to give us 209.80. Okay? Everybody good with that? All right. So now we're going to give a 5-number summary and draw the box plot for each of the 2 sets. We don't have to draw the box plot. We just have to pick the one that's right, okay? So give the number summary for the East Coast counties. So the lowest value, well, that's pretty simple to find. That's going to be 104.7. The median, we've already found, so I hope you could just copy it down, right? The highest, okay, so now we want the lower quartile. We're going to start at the middle, and it's going to be the one in between these two. So that would be 123.3, right? Again, we're going to start at the middle for the upper quartile, and it's the median of this half. So that's going to be 141.3. Okay, so that's how you find your 5 numbers. Okay, now we have to look at this, and from our 5-number summary, pick the box and whisker plot. That is correct. So we know our lowest is 104, our highest is 314, and then our median is going to be the line in the middle, right? Well, this one's wrong because it doesn't have any whiskers, right? So we know that's out automatically. So this should be about 123. And this one is over 130, so that would count it out, right? That one's out, this one's out, and this one's out. So let's try this guy. 123 would be about 123, right? So that would be good. This would be the one we would want to use. Okay. Okay. So the standard deviation for the East Coast counties I have to go back and find my page. Give me a second. So our mean, you have to find that. So our mean is 157.93. Okay. Probably help if I would keep my, there we go. We could keep our numbers over here. So we're going to have 104.7 minus 157.93, right? 123.3 minus 157.93. 128.9 minus 157.93. 134.9 minus 157.93. 141.3 minus 157.93. And then our outlier, 314.5 minus 157.93. Okay. So let's see what these are. So this is going to give me a negative 53.23. Right? This one's going to give me a negative 34.63. Negative 29.03. Negative 23.03. Negative 16.63. And the outlier is definitely going to give us a positive, right? 156.57. Okay. So this was our deviation. Remember that? This is our deviation. Now, we need to find our deviation squared. So we're just going to put parentheses around each one of these. Deviation squared is our next step. We're going to square each one and see what we get. Okay, so negative 53.23 squared is going to give us 2,833.43. Now, negative 34.63 squared is going to give us 1,199.24. Negative 29.03 squared is going to give us 842.74. Now, negative 23.03 squared is going to give us 530.38. Negative 16.63 squared is going to give us 276.56. And 156.57 is going to give us 24,514.16. Okay. So now this, all of these are our deviation squared. All right, that's what we got there. Okay, so we have to total all these up and get our sum, right? When we add these, we're going to get 30,196.51. Okay, so this was our sum. We always take our sum and we divide it. We had 6 numbers, right? 1, 2, 3, 4, 5, 6. We divide it by 1 less than the number that we have. So we had 6, we take 1 away, we divide that by 5. So 30,196.51 divided by 5 gives us 6,039.30. Now, once we've done our division, we take the square root of that, and that gives us 77.71. So the standard deviation for the East Coast counties is 77.71. 0.71. Okay? Okay. So now, we're going to assume that a set of test scores is normally distributed with a mean of 100 and a standard deviation of 5. So we're going to use the 68, 95, 99, 7 rule to find the following quantities, okay? So let's draw that. So here's our mean, right? So we know one standard deviation away, so this is -1 standard deviation. This is 1 standard deviation. Then we're going to have 2 standard deviation. And then we have 3 standard deviation and -3. Oh, standard deviation. I was just going to trick him up and put him up there, but I didn't do on the other side. Okay. Right? Okay. So we know within this area, this is 68%, right? Just by our rule. And then within this area, this is 95%. I'm just going to draw it over. And then within this area, this is 99.7%, right? By our rule. Okay. So we want to know the percentage of scores less than 100. Okay, so if we're looking at that, I'm going to use, what color do I want to use? Brown. So we know, first of all, we know that the mean is 100 and the standard deviation is 5, right? We got that right here. Mean is 100 and the standard deviation is 5. So if it's less than 100, like here is 100, right? The mean was 100. So if it's less than 100, like from here over, that's going to be 50%, right? Because that's less than 100, or if it's more than 100, that's going to be 50%, right? So percentage of scores less than 100, well, that's going to be 50%. So the percentage of scores greater than 105, well, 105, so if this is 100, we know that the mean is 100, and the standard deviation is 5, so if you go up 1 standard deviation, that's going to be 105, right? So then this one is 105. I don't know where to write that. How about here? 105. This is going to be 110. This is going to be 115, right? This is going to be 95. This is going to be 90. And this is going to be, I left no room here, 85. I wish it wrote my 50% so big. Okay. So we know that 105 is 1 standard deviation, right? And 1 standard deviation is 68%. But we have to take that 68% and divide it by 2. Because it's not the top half, it's the bottom half, right? So that 68 divided by 2 is 34%. So this half is 50%. So if we have 50% and we subtract 34% from it, that's going to give us 16%, right? So, because we know 50% was already less, was more, and then so 50% was less. So we had the less than, and then we took that away from it. So this gives us 16%. Now, we want to know the percentage of the scores between 90 and 105. So I'm going to change color pens. This one's good. So this is between 90 and 105. Okay. So 90 is 2 standard deviations. And 105, we know, is 34%. Right, we've already figured that out. So if we take, 2 standard deviations, okay, so 2 standard deviations, we know that that's our 95, right? So here we're going to have, this is going to equal 95%. Once again, we're going to divide that by 2, right, because we're just down here. So that's going to equal 47.5%. Okay. Now, if we have 47.5% and we add the 34%, that's going to give us 81.5%. So that is the amount that lies between 90 and 105. Okay? Okay. So now we're going to look at the scores on a psychology exam. Doing a lot of testing today, aren't we? So the scores on a psychology exam were normally distributed with a mean of 62 and a standard deviation of 6, right? So our mean is 62 and our standard deviation is 6. What is the standard score for an exam score of 61? Okay, so remember our standard score is always Z. So the standard exam score is 61, so we're going to have 61 minus our mean, which is 62, all divided by our standard deviation, right? So that's going to be divided by 6. Well, this is going to be a -1 over 6, or it's approximately negative 0.17. So that's your Z score, right? Or your standard score. Okay, that's how you do that one. Okay, so we're going to use this table to find the standard score and the percentile of the following data sets. Okay, so the data value, 2.2 standard deviations, this is the important word, below the mean. So if it's 2.2 below, we're going to find negative 2.2, right? Below the mean. So that's 0.39. Okay? Now let's look at the data value of 0.6 standard deviation, again, below the mean. So we're going to find negative 0.6, and that's going to be, different color please, 27.43. Now let's look at this one. We have 2 standard deviations above the mean. So this time we're going to go to 2 above, and that's 97.72. Okay, so these are the key word. Below is negative, above is positive. Okay? Don't forget to look for those. Okay. Okay, so suppose we describe the weather as either balmy or humid. Answer parts A and B below. So, using the letters B and H, list all possible outcomes for the weather on 2 consecutive days. So we want 2 days, right? So on day 1, we could either have a balmy day or a humid day, right? And then on day 2, we could have a balmy day or a humid day. Or a balmy day or a humid day. I noticed on y'all's quiz, like y'all would put balmy, humid, and then y'all would switch them and put humid, balmy, humid, balmy. Like if you have BH, do that on this one, BH, BH, right? And then if there's a third one, BH, BH. So like keep it all the same, like don't flip them, okay? Like, but if you start with H on top, then keep the H on top on every one. Don't make it all willy-nilly. Keep a pattern. Okay, so now we want to find our outcome. So we're going to follow this leg. So you go all the way up this leg. So you go B, B. So B, B is your first outcome. Now you go up this same leg here, and you go B, and then you go down this leg, H. Okay, now we're finished with that one because we've done both of these. Now we go down the next one, H, B. And now we go down this one all the way straight, H, H. Now, we knew that there were two options. It could be balmy or hot, and we had 2 days. So 2 squared is 4. And we got 4 outcomes, right? There you go. So we listed all the possible outcomes. So we're finished with this one. Now let's go to the next one. If we are only interested in the number of B days, what are the possible outcomes for 2 consecutive days? Okay, so here's our events that can happen. This was A, sorry. So here's our events. Possible. So we can have 0 balmy days, right? This one has 0 balmy days. Or these have 1 balmy day, so we could have 1 balmy day. Or we could have 2 balmy days, right? Those are our possible events. And that's the answer for B. Okay. So now, number 8. Use the theoretical method to determine the probability of the given outcome or event. Assume that if the die is fair, rolling a single 6-sided die and getting a 3, 4, or 5. Okay. So the probability of getting a 3, well, we know if we roll a die, it's going to equal 1/6, right? The probability of getting a 4, if we roll it, it's going to be 1/6. Probability of getting a 5, well, again, 1/6. So now we are going to use our theoretical method, which we know is 1/6 plus 1/6 plus 1/6, right? When you add fractions, you do not add the denominator. So that is going to equal 3/6, which will simplify to 1/2, right? So that's your answer. Okay. And if you need to draw your little diagram over here, 1, 2, 3, 4, 5, 6, to figure out what those were, then you can do that, okay? Right on. Okay. So determine the probability of selecting a 2-child family with 1 boy and 1 girl, assuming boys and girls are equally likely. So we're going to have a 2-child family with 1 boy and 1 girl. So 2 kids, there's 2 options, so we know our outcomes are going to be 4, right? So here's the parents. They have kid 1. It's going to be a boy or a girl, right? This is our first kid. Then they have kid 2. Again, since I wrote boy on top the first time, I'm going to write boy on top the second time. Cool? Now, run your legs. Boy, boy. Again, boy, girl. Girl, boy. Run your leg again. Girl, girl. Okay, that's all 4, right? We knew we were going to get 4. We got 4. Happy day. Now, we want the probability of boy, girl is what we're looking for. So we want the probability of boy and girl. So let's look and see. Different color, shall we? This is boy, boy, not what we're talking about. This is boy, girl. Yeah, baby. This is girl, boy. Same thing, right? It's 1 boy and 1 girl, so we're going to take it. This is 2 girls, so we don't care. I don't know what color this was. So we have 2. So this is 2 over 4, right? Well, this simplifies down to 1/2, so our probability was 1/2. Okay, that's how you do it. All right, so you toss a coin 200 times and get 38 heads. We're going to complete these parts. So A, determine the relative frequency probability of the coin landing heads up. Okay, so A, probability of heads. Well, we got 38 heads out of 200 times, so that tells us it's going to be 38 over 200. What does that simplify down to? Well, they're both divisible by 2. So that would be 19 over 100, or 0.19, right? Okay. B, determine the expected relative determine the expected relative frequency probability of the coin landing heads up. So, well, that's easy to figure. Flip a coin. What's the expected probability? We're going to get heads or tails, right? So the expected probability is 1/2. So now let's answer C together. Do you have reason to suspect that the coin is unfair? Yes or no? And why? That'd be 1, right? Yes, because the relative frequency is not near the expected frequency. I mean, this is 19, and this is 0.50. I mean, that's a big difference, right? So it would be yes. Okay. So we're going to determine the probability of the given opposite event. So what is the probability of rolling a fair die and not getting the outcome less than 2? Okay. So the probability of getting a 2, right? Less than 2. I should think about what I'm writing down. Let's just say P of A. That's going to be 1/6. Less than 2 would be a 1, right? And then let's say P not A. We know how to find not A, right? It's 1 minus P of A. Okay. So we're looking to find P not A, right? Given the opposite event. So we're looking for P not A. So this is going to be 1 minus 1/6. So P not getting less than 2 is going to be equal to 5/6. I wrote it the weird way. So 5/6. All right. So find the odds for and the odds against the event rolling a fair die and getting a 3, a 2, or a 5. Okay, once again, you know, like when we roll a die, 1, 2, 3, 4, 5, right? We got that. So the probability for a 3, a 2, or a 5 is what we're looking for. So the probability for a 3, right, equals 1/6. Probability for a 2, 1/6. Probability for a 5, 1/6, right? So when we add those all together, 1/6 plus 1/6 plus 1/6 equals 3/6, which is 1/2. We've already established that, I don't know, last page, I think. So odds for so that's going to be 1/2 divided by 1/2. So remember, keep, change, flip. So we're going to keep the first one. We change the division, the big division bar, to a multiplication, and then we flip the bottom one. So that would be 2 over 1. Remember, I did it on the board. Now, our 2's can cancel, becoming 1's. So 1 times 1 is 1. 1 times 1 is 1. Okay? So our probability is 1 and 1. Odds for, 1 and 1. Okay, let's do another one. So odds against. Okay, again, we have the same, right? Odds for leaves 1/2 for odds against. So this time, we have P not A, right? This was PA divided by PA. Same thing though, right? 1/2 over 1/2. So that's going to equal 1/2 times 2 over 1, which equals 1 over 1. So just works out that this one is the exact same. Because odds for, I probably should have wrote that. Odds for is PA over P not A. Sorry. When they look exactly the same, it's kind of hard to tell what I did. You know. Okay. Okay. All right. So we're going to determine whether the following individual events are overlapping or non-overlapping. Then find the probability of the combined event. Getting the sum of a 7, 10, or 11 on a roll of 2 dice. Okay. So here we go. We're going to see about getting a 7, 10, or an 11. Okay, so remember that big firework looking one? Yep, that's this one. So we're going to start out here. We have our 1, 2, 3, 4, 5, and our 6, right? So here's our 1, our 2, our 3, 4, 5, and 6. Okay, little cheat. Remember we have 6. There's going to be 2 rows. That gives us 36 outcomes. Okay, let's go. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6. Sometimes I run out of space and have to do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Y'all like me counting like that, don't you? 1, 2, 3, 4, 5, 6. Okay. So. All right, got all that. Now, remember, we have to go up the row and add them. So 1 plus 1 is 2. 1 plus 2 is 3, 4, Okay. So up here we start with 2. On the 1, we start with 2 and we go to 7. On the 2, we start with 3 and we go to 8. On the 3, we start with 4 and we go to 9. On the 4, we start with 5 and we go to 10. On the 5, we start with 6 and we go to 11. On the 6, we start with 7 and we go to 12. Okay, so whatever number our original row was, we then start with the next number and go to 7, right? You see that? You see the pattern? 2, we start with the next number and go to 8. See that? Okay, so that's where we are now. So what we want to do is we want to get the sum of either 7s, I circled that so bad, 7, 8s, or 11s. So let's get a different color now, because I love the colors. So we're going to circle all the 7s, all of the 10s and all of the 11s. So here we have a 7, right? Here we have a 7. 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 And here we have a 7. Cool. Now let's jump over to the 10s. We don't start having a 10 till down here on the 4. First 10. We have another 10 and another 10. Now 11s, our 11s don't start till down here on the 5. So we have 2 11s. Now we're going to count how many circles we have. Cool? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 circles, right? So that is 11 over 36. Individual events, non-overlapping, right? Because our rolls wouldn't overlap. There's no way they could, right? One roll, then you pick them up and you roll them again, so there's no overlap. Cool? Everybody good with that? Okay. Everybody can draw that, right? I mean, we've drawn it twice now. Okay. So we're going to use the at least once rule to find the probabilities of the following event. Getting at least 1 heads when tossing 3 fair coins. So we know we're going to toss 3 coins, right? So let's look. Our n would equal, you guessed it, 3, right? Probability of getting heads, we should know this by heart now. So the probability of heads is 1/2. And P not heads, well, it can only be 1/2, right? Okay. So our at least once rule is 1 minus our not h, so that's going to be 1/2 cubed. Well, we know 1 cubed is 3, 2 cubed is 8, so this is 1 minus 1/8. Right? Put it in your calculator, or you could say 8 over 8, and then 8 minus 1 is 7. So this is 7/8. However you want to do it. If you want to do it in your little brain, you can, or if you want to do it in your little calculator, you can. Either way, right? Okay. Let's talk insurance now. Everybody's favorite. An insurance policy sells for $600. Based on past data, an average of 1 in 100 policies will file a claim for $20,000. An average of 1 in 250 policies will file for $40,000. And an average of 1 in 400 policies will file for $80,000. Find the expected value per policy sold. If the company sells 30,000 policies, what is the expected profit or loss? Okay. So we know expected profit. So the first one, right, was 1 in 100. So that's our, and we multiply that by 20,000. Right. And then we add. When it's expected profit, we always add. So that was our first one. Now our second one is 1 over 250, right? And we're going to multiply that by 40,000. Again, expected profit, add. So that was our 40,000. Our next one is going to be 1 over 400. And then that is 80,000. Okay, that's all we got. Right, done. So now let's find out what that is. So that's going to be 200 plus 160 plus 200. So that equals $560. So we know that the insurance policy sells for $600. So if we take 600, change colors. So we got this from here. We take this 600 and we subtract 560, right? Because they sell it for that. This is how much they're going to put out. So it's going to be $40. So if we take the 30,000 policies times 40, That's a lot of dollars. That is a lot of dollars. Right? Oh, insurance. Gotta love them. Okay. Let's do this one. Answer the following question using the appropriate counting techniques, which may be either arrangements with repetition, permutations, or combinations. Be sure to explain why this counting method technique applies to the problem. So, how many different 4-digit codes can be formed using digits 0 through 9? Well, we know that we have 10, right? So our N equals 10. And we're making a 4-digit code, so our R equals 4. So this is going to be N raised to the R, right? Or 10 raised to the 4, which gives us 10, 1, 2, 3. Since it's raised to the 4th, you know to put 4 zeros after the 1. Fun cheat right there. All right. And it's arrangements with repetition because the selections come from a single group of items and the order of the arrangement matters. So, arrangements. Okay. Last page. Right on. So, answer the following question using arrangements with repetition, permutations, or combinations. How many anagrams, rearrangements of the letters camp phone can be made? Well, since it's a rearrangement, right, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 factorial. And that is 40,320. Okay? Remember, factorials is the same thing as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? When you put it in your calculator, you say 8, math, go over 3, and then go down 3. All right? That's how you do it, just in case y'all have forgotten since you got home. Sometimes I forget things when I get home. Sometimes I just forget things. Okay, let's do the next one. Answer the following question using arrangements with repetition, permutations, or combinations. Be sure to explain why the particular technique is applied to this problem. So a dog shelter is giving away 15 different dogs, but you only have room for 5 of them. How many different dog families could you have? So would order matter? That's what you would have to ask yourself in this, remember? Because with permutation, order matters. Combination, it does not. So would this be in choose R or in pick R? That's what you need to ask yourself. If you said order does not matter, you would be correct. So it would be in choose R. Our N is going to equal 15, right? Because there's 15 different dogs. So N equals 15. Our R equals 5. So let's just go, right? So this is going to be, this equals NPR over R factorial, okay? And then that equals, I should have put all this down to start with, N factorial over N minus R factorial times R factorial. Okay. So, with that said, that's going to be 15 factorial. Ooh, I forgot my little dot. And then 15 minus 5, 10 factorial times 5 factorial. Okay, and then that is going to equal 3,003. All right then. So this would be combination. Should be used. No item may be selected more than once, and the order does not matter. So that's why we chose combination. Okay, guys. Thanks for being cool and us going and using this way. Sorry that we were behind and had to do this. But the cool thing is you could run it back. You could slow me down. You could speed me up. Yeah, and you could always ask questions in class, okay? So here this is. I'm going to open this as soon as we come to class Tuesday, and then you have it. All right. Peace out.